Hey everyone, Tony Bontragaluppo here from Bantam Tools. I've got Peter Riley and Amanda. Oh my God, how did I screw that up? Amanda Bender with us here. Wow, I am off the Christmas card list. Peter Riley, Amanda Bender, our marketing team here at Bantam Tools, and we are going to talk about CAD and CAM today as part of our kind of ongoing Q&A series. I know I have a lot of questions about CAD and CAM, and so we're just going to step through a project that is in one of our projects that we offer up in our support docs, and we'll show you step by step how we do it and iron out some of the questions. I'm kind of a newbie to this world, so I'm learning things bit by bit and trying to just find those spots where it might not be immediately obvious exactly how to proceed, where there is jargon that gets used that maybe a first-time user doesn't immediately understand. So I'm going to try to make this as easy for somebody starting from scratch to get into. If you're an experienced machinist, beware, this is a very much a 101 oriented conversation. But if you wouldn't mind a refresher on that, feel free to stay tuned. So again, I'm Tony Bontragaluppo. Pete, do you want to introduce yourself and then pass it over to Amanda?
Yeah, absolutely. So anyways, I'm Pete. I'm working in marketing along with these two, and I'm the one that's doing a lot of the videos and coming up with some of that original content that we're seeing here at Bantam Tools. And then I've been learning very publicly and how to use the mill. So I'm very much, while I've been doing this for a couple of years now, working first in the PCB mill, now working with the CNC mill, I'm still very much new to this world and have a lot of fun learning every single day. And so I'm excited to be able to share some of the things I went through and, hopefully kind of steer you in the right direction as we go through it. It can be a daunting experience sometimes if you look at it as a whole, but just remember it's step by step. And then eventually you're gonna be looking back and you realize how many things you've learned and how far you've come.
Yeah, I mean, jumping off of that, Pete is making some amazing projects. Last week, we actually shared a wood joinery project, and that was something that a lot of you guys got excited about. So that was cool to see. More specifically, I manage social media for Bantam Tools and juggle a couple of other projects, but mainly social media, and then also all of our support guides, written project guides that you guys might see as you peruse our support center. I have a hand in creating those. And so me, Pete, and Tony all work pretty closely together to get those support materials created for you guys. And so I guess the big thing there is, like, if there is ever a question that you guys have and you're like, I need more guidance on this, reach out to us. We're always open to getting your feedback because we want to know what you want to learn more about. Just like, the CNC Q&A is for answering your questions. Us creating videos and written guides around that stuff as well is what we are aiming to do.
Thanks for that, Amanda and Pete. So how do we get started? We're going to get into Fusion 360. And just to kind of get everybody up to speed on how this is going to go, there's kind of this process when you're going to make anything on a CNC machine where you're going to have to kind of create the design. That's CAD, computer aided design. And then you're going to have to create instructions that will tell the machine how to actually move the tool across the surface in order to machine this design into reality. And so that's CAM, computer aided manufacturing. And then there's the actual process of passing those instructions to the machine and creating the thing. And so what we're going to focus on are those first two parts, the CAD and the CAM, laying the groundwork for the actual machining, which we'll cover in a future segment. And so today what we're going to focus on is largely going to be in Fusion 360, where we're going to kind of set up our space, draw something, and then set up the tool paths and get it ready to be made. Do I have that right, guys? Wonderful.
Yeah.
You're good.
All right, great.
Look at you go, Tony. You're doing so good.
What's that?
You're doing so good.
Thank you. So this is a getting started project from our desktop PCB milling machine, which is the previous model. Right now, we have the Bantam Tools Desktop CNC Milling Machine, which is available now, which is a little bigger, a lot more powerful, a really capable thing. Pete's got his over in his place. I've got the PCB in my place here. But we're running through this project, which is just a very straightforward project of making a ring, which means essentially drawing a circle. And so, Pete, do you want to walk us through kind of setting up the initial space in Fusion 360, or would you like me to do that?
Well, no, I guess particularly let me know where you're at, and I'll just kind of talk you through it here, because I know we've talked a little bit about it briefly, but let's dive in and let's see how much you've retained and if I did well in explaining some of this stuff earlier. Let's do that.
That is very fair. So I will say first of all that my keyboard is acting strange, and that's why everything has been so weird. So give me just a second with that. Okay, I'm just gonna use my other keyboard.
All right. Without my other keyboard. What? How many keyboards do you have?
Well, it's like my external versus
That's
my
like the
laptop.
definition of like a true marketer right there, who just like works online.
As long as your left hand knows what your right hand's doing, you're going to be okay. That's how you
Exactly.
get away with 2 keyboards.
Exactly. So I'm going to pull up Fusion 360. All right, so here we are. We're in Fusion 360. This is on my computer, and I'm a newbie, so I'm still kind of getting the hang of all of this. I know that we have this data panel on the upper left corner, which when we first talked about this, that was kind of what we talked about. This is where we'll be able to kind of manage our projects and things like that. We're not really going to spend much time in here, but it's a good kind of starting point to see some of the things you could load up. And I see, just looking at it now, we've got these samples and hands-on exercises. So if I want to just get in here and learn about the software, I'm assuming there's a lot that I can play with here.
Yes.
Yeah, Fusion has a really extensive archive and support library, which it's a whole rabbit hole, but like there's so many good resources there. 10 out of 10 would recommend checking them out. I know that helped me out a lot when I just started to take the dive. So I don't know how you feel about that, Pete, but I think we both have gone down that rabbit hole.
The nice thing is, Fusion 360 is a very robust society or community around it. And so there's a lot of stuff out there, not only from the folks at Autodesk, but also just the folks that are using it, because it is comparatively a very accessible program, and they keep getting better. So that's
Love
awesome.
They're clearly investing a lot in trying to make this project, this software, as accessible as possible, which is good because it is a very robust system. There are some nuances to how to use it, and at the same time, you can really step through this process without it being too complicated if you know kind of where to go. Mm-hmm. So the next area that I want to highlight is this big old block that says design. This is kind of emulating the Microsoft Office ribbon style of having all of your different kinds of tools and things. So there's kind of subcategories of things. But this design thing lets me go to different areas. And the areas we're, I believe, going to focus on are essentially design and manufacture. We're going to start in design, and then we're going to go over to manufacture. We're going to play with these new tools that you can kind of see. They do a very clever job, I think, of just demonstrating through these iconographies what these different things actually represent. And you can see how that kind of black line over the blue surface indicates how the tool is going to move along the material. And then to make it even better, you've got these awesome mega tooltips that have really descriptive explanations and more complex diagrams that kind of show you examples of the different kinds of things you can do. So if I'm working a new project and I don't have the benefit of having 2 amazing folks helping me out, I might be able to kind of fumble around just by looking at what's here and say, this actually looks as close as possible to what I want to do. Maybe I'll try that.
That's exactly it.
Right?
No, that's exactly it. It's about experimenting, figuring out what works. And you're right. As with most everything in Fusion, if you don't quite understand something, just put your mouse over it and wait a moment. And it just pops up these wonderful, great things that kind of tell you more about what's going on. And it's definitely helpful. And because there's a lot of different things and you can get deep into things, it's helpful just even as a reminder. Even at this point, I've been using this now for a couple of years, and I still, on certain things, I'm like, okay, how does that work? Let me get a quick refresher. So good pointing that out. And you will be working in the 2 spaces. First, there is the because the design workspace and the manufacturer workspace, the two big things you're going to be using primarily when working with the Bantam Tools Desktop CNC Milling Machine. And like Tony mentioned, there's CAD, which is where you create the thing, and there's CAM, where you create the tool paths, like the directions for making the thing. And so we're gonna, Tony, I think we're gonna try and do a little CAD recap. So we'd want to kick over to the design workspace, and I guess we'd start. Usually, you'd start with a sketch, which is usually the easiest way. So you're gonna start with something flat, draw out some circles. Think of it like blueprints or architectural drawings, things like that. Like you might have seen these before, where it's like a bird's eye view of something. And so what you're going to do, in this case, it's a ring. So it's going to be pretty straightforward. We're just going to try and create a ring shape.
All right, so I'm going to go, and I think I'm wondering, should I start with a, no, this isn't where we did last
We actually
time,
want to
was
create
it?
a sketch. Yeah, we're going to do it with a sketch this time. And let's
Great.
do it that way. So if you go ahead and click on create sketch, under create, the first thing it's going to ask us is, where do you want to put it on which of these three planes? Because you're working in a 3D space. And so we just basically need to put a stake in the ground. This is where we're starting. Usually you can click on either of those faces. I usually click on the other one there, that one right there. And I make that where I'm going to work off of.
This kind of represents the bottom of the surface, so I'm going to kind of build up from there, essentially, right? And one thing I realized kind of after we had started walking through this previously is that in this top right corner we've got this kind of view indicator as well, which also shows us top, front, and right. So you can get a sense of, you could imagine that the intersection of the blue and the red is the front left corner of your machine when you're looking at it, when you're facing it, which is how we orient the Bantam Tools software as well. So I'm going to just go ahead and click that. Okay, and it went whooshoo, and now I'm kind of in a two-dimensional mode. I imagine kind of bird's eye view looking straight down on the surface. And this is the corner, so I'm going to kind of build outward from that lower left corner.
Exactly. Once again, you don't have to stress too much exactly where you start, but just once you start, you're just kind of everything's relative from wherever you decide to start. And in the top right corner on the cube you're turning, you notice how it says top right now. So that's just letting you know where you are in this three-dimensional space. You're looking at the top of whatever you're making. So
got it.
You already picked, and this is great, you picked the circle tool, which is, there's a couple different options in there. And you did the center diameter circle, and that's what we're going to do. We're going to try and create a ring. Hey, by chance, do you know what your ring size is? Have you measured?
Off the top, my like this actually.
Yeah, actual ring finger.
No, okay. I do not. Do I need? Well, how do I do it? Do I use my calipers?
You could use your calipers if you have to, yeah. Or you could look up common ring sizes if you already have a ring size that you know. Okay. But I could do that. And this we can be much more precise. In the PCB getting started project that we're kind of going off of loosely, it actually recommends taking a piece of string, tying it around your finger, and then cutting it and then measuring that length of string. I think that's pretty smart. Or if you have or maybe like a measuring tape that you would use for, for your waist. So what do you got, Tony? What are you looking at?
0.63
for that.
Inches.
Okay. Inches is important.
Is that comfortable, or are you clamping down hard? Because
it's like cozy. It's like snug.
Okay.
I'm trying to do this without flipping anybody the bird.
Thanks.
All right. Very good.
So let's create a circle then that would represent that internal diameter of 0.063 inches. And I see that you're actually sitting in the metric workspace, which is fine. The nice thing about Fusion is if you were to type in I'm just gonna have you do it this way first, and then we'll change it in a sec. But go ahead and type in, if you type in 0.0 or 0.63. Oh, that's right.
It kind of like when I did that. Okay, I'm clicking and I'm dragging.
Okay, so
I'm gonna let go.
If you just let go,
but it's still. I've let go, but it's still okay.
That's fine. It's gonna follow because right now you've got it. If you start typing, it's gonna allow you to type in whatever. So 0.063, but exactly 0.063 inches, and it'll do the conversion
for you. So it switches units dynamically.
Yes.
Or it'll convert it dynamically, essentially.
Yes.
Great.
So that's very helpful when you're going back and forth between standard and metric, which you tend to do.
So is this telling me that 0.63 inches is the equivalent of 16.002 millimeters?
Correct.
Exactly.
And that little slashy zero is diameter, in case
Mhm.
anybody's wondering.
Hmm.
Very cool.
Exactly.
All right, great. So now I've got my circle.
Yep. And so the other thing, so from there we can go ahead and we want to draw like another circle because we're going to make a cylinder, right? So a tube shape. And so there's a
Mm-hmm.
couple ways you can do that. We can either draw another circle and we can do the math, or you have the concentric tool. I believe that's what
Mm.
that's called up there. Forgive me if I got that name just right. If I got
Yeah,
that name wrong.
concentric.
Great.
Mhm.
And using this one, you can sit there, you can then choose, click on that circle, and you can start to draw out. So go ahead and use that little concentric tool. So it's actually active. We're not on it. Right. Oh, not that one. Go to the left. It's over there by the scissors.
I think we need to go under modify and constrain, don't we?
Oh,
Or offset
over.
it.
Oh, sorry. I'm looking for
Offset.
offset, not
Yeah,
concentric.
I know
Yes.
what you're looking at.
Bingo.
You're looking at the
Okay.
icon, Pete, because that's what we want it to look like.
Yep. Sorry.
Yeah.
Offset's the
I
name of
think
the
we do
thing.
the offset tool, not like we're not working with constraints. We
Yeah,
want it
sorry.
to stay.
Sometimes the images are deceptive when we want it to look like that, but that's not
That's why we have to hover.
Well, we're creating concentric circles using the offset tool. So
Yeah,
using
exactly.
the offset
That's
tool,
basically what we're doing. Yeah.
we've got some options here. So now using that little slider. So this is, in this case, we're going to do something that'd be like 1 millimeter thick, if you wanted to. And so this is kind of up to you on whatever you feel is going to be reasonable. Usually if you're going to do like a ring that you're actually going to wear, you wouldn't want it to be terribly thick.
Right. Any recommendations?
Probably about 2 millimeters. That seems to be about good. Two to three would be reasonable. 3 if you want a little bit of heft, if you want to feel like you've got it. I mean, if we're going to be cutting this out of aluminum, it's super light. And, it's something else you can show off to friends and sit there and spin on the table if you wanted to.
One ring to rule.
Great.
Cool.
Oh, I had the impulse to save it, so
that's all right.
I'm going to do
Good.
that now.
One of the things,
and
you brought up a good point here with this. One of the great things about this with Fusion is that it will actually keep track of stuff. So if for some reason you do crash or something like that, it's actually doing backups even on untitled projects, ones you haven't even saved yet yourself. So when you launch, it'll give you a chance to bring that back up. It's rare that it does crash, but if you do something, if you do something stupid,
it's usually when you overload it, Fusion just goes, okay, guys, like I need a minute.
It's usually me crashing it with some other program I'm doing because I'm trying to do too many things at once. And so, it'll give you the prompt and you can just kind of pick up where you left off. So go for it whenever you're saved. We'll jump back in. I think.
I'm not going to worry too much about admin versus default project or that. It's fine.
That's project management, and that's a little more. The Fusion has some great documentation about that as to where you're saving things. Ultimately, you're saving projects on a cloud with at Autodesk, and then that way you can access your projects everywhere you go. And then
and
each
you can
project
just as easily share those projects.
Exactly.
It's a whole rabbit hole. Like they've done a lot of work on that end where you can share documents and access documents, and it's really meant to be a collaborative tool from whether you're 2 feet apart or you're, working remote like many of us are.
Right. So this has a lot of collaborative capabilities built into it because I'm sure there's big complex team projects that multiple people working on the same project are going to be, wanting to stay in sync.
Exactly. And so, Tony, I guess we should probably extrude that sucker. So we can finish up the sketch. We've got the sketch the way we want, unless you want to talk to the fact that if we wanted to resize it, this is actually kind of interesting with the dynamic sketches.
Why don't you tell us about that real quick, and then we'll move on.
Yeah, exactly. So let's say you decided that your ring finger needs to be a little bit larger. If you were to actually double click where it says 16.002, you can now re-enter a different dimension. Again, that's the converted to inches. If you want to do, full 1 inch. There you go. It's going to do that dynamically.
What's nice about the offset is that it's dynamically offsetting from this. So I can change this and this automatically just bumps out because it's being calculated relative to this inner circle.
Mm-hmm. Exactly. So
I imagine Yeah.
Yeah, we put it to
I'm sorry,
recap. I was going to say to recap, we put a stake in the ground. We were in three-dimensional space floating everywhere. We put a stake in the ground, said, all right, this is where we're going to do it. This is the bottom. We drew a circle that was relative to that stake in the ground, right? And then we went further and said, well, I want you to draw another circle that's based off that circle. So everything is based off the next thing. And so it all builds.
And I
It's
imagine that really comes in handy as the projects get closer because they get more complicated.
exactly.
Absolutely.
That's like in this particular instance, like I know people are like, I can just draw like another circle. And in this particular project, that's totally fine to draw two circles. And it's very easy to modify those two. But when you get into much more complex models, when you've hit it right on the head, like to go back and tweak every last thing that you've sketched, that becomes tedious. And also it opens you up for like more, there's a lot more room for error there. So,
I imagine that means that when I'm in the design process, that there are some best practices around how I think about drawing my project so that if things are going to potentially in the future scale relative to other things, that I draw with that in mind.
right, exactly.
Yeah.
Like I think
Okay.
when I first started drawing in CAD, I was very deliberate. Like I would do two circles. And then as I've now modeled, not super like I don't want to say like there's like super complex parts, but just complex enough where I'm like, oh, I want that feature to be different, but because I'm moving this feature over here, this one needs to move. And so using the modify tools, also utilizing the constraint tools, they become more and more helpful. And so like I would just vote to experiment with them, like especially like on projects like this, just to see what they allow you to do and how allows you to like modify your model. That usually becomes helpful down the road as you start to expand on what types of designs you're creating.
Got it. Okay, great. Great. And now we've got it in 2 dimensions. But in order for it to exist in reality, it's got to go to 3.
Exactly. So we're done with our sketch part. So we're going to go ahead and we can click on finish sketch. You got 2 spots where you can do that. In the top right or also in the dialog box that popped up on the right.
I always forget about the green check
down
mark
here.
in the top.
Neat. Okay. Cool. All right.
Great.
Finished.
Now I have a sketch. Now, if you want to just to show that this is 2-dimensional, you just want to navigate real quick through a little cube and you can show that this is with your, there you go, there's a little navigation cube in the corner. If you just click and drag on that, you can start to move this around. You're going to start to see that we have literally just drawn a flat shape
Cool.
that has nothing to it. But we are into 3D things that we can hold. Let's bring it into the real world. So let's go ahead and let's create some, let's create the shape. And the easiest way in this case is using the extrude tool, which you're going to use a lot when you're working off of sketches. So you can find the extrude tool under the create dropdown, or you can hit E as your shortcut.
Got it.
And there's other tools that work similar to that, and they're all nested in there, and you can play with those and learn those at your leisure.
I have to say, Pete, I'm very tempted to drag this arrow up and down.
Do it. See what it
'Cause
does.
I feel like it's going to 3Dify my thing.
3D.
Whoop, 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 whoop. Oh, yeah. Look at that.
So there you go.
Cool.
So you are extruding from the sketch that you made, and you're extruding up or down, either direction you want to do. And then as with everything in Fusion, there's an option to enter in something exact. So since that's highlighted blue right now, if you just start typing, you can make it whatever you'd like it to be. That's reasonable.
I put in 0.06 because that is the thickness of the material that I measured with my calipers.
Okay, great. So that's what we'll work with today. Just gonna say, go,
That's actually, I need to pause for a minute. Like, this is actually something that is really important to take into account when you're designing something. If you're in a machine shop type setting or like a studio type setting, you might have like a lot of stock on hand. But I think like, especially like for me right now, I'm milling out of my house or my apartment. And so like, I don't always have like, I have different size stock all the time, like taking it into account, like the thickness of your stock when you're designing in CAD can help you later down the road when you're programming your cam. Because when you program your cam, and we're going to be talking more about this shortly, like during your setup, you're going to have to input those dimensions. And I can't tell you, like, especially when I first started, I can't tell you how often I would like design the thing. I would go and measure my stock and I would realize, well, the design is bigger than the stock.
Yep, which can be absolutely heartbreaking.
It is.
You've got
It
this
is
wonderful
totally
thing, and you go, man, I'm over by a 1/4 inch. What do I do if I shrink it here? It causes this to be too. Yeah, it becomes a whole mess. So no.
Yeah, that's what I mean. Like it's absolutely, it's gut wrenching because you're like, no.
So you're starting to talk about how the physical world does impact what you're doing
Yes.
in the digital realm. So you kind of have to keep that in mind. There's things that we'll talk a little bit in a moment that when we get into CAM about that we have to consider with tool shapes and how the tool comes down, interact with things. But yeah, stock size is definitely something you want to think about early on when you're creating your design. And then the nice thing is the Bantam Tools Desktop CNC Milling Machine, you've got quite a bit of build volume with upwards of 9 inches by 7 inches by 3.5, which is quite large. And that you can be working with metal, so you can create some hefty things with that build volume. PCB mill that Tony's using, small but mighty, but small kind of being the word comparatively. It's smaller, so we don't quite have room. So he's working with a little bit of smaller stock.
So I'm gonna go ahead and measure this guy. I got my little piece of aluminum here, and I got my calipers, which are set to inches right now. And I'm just gonna go ahead and kind of squeeze it together, and I could see.
Look at that.
Boom.
0.06 on the dot.
And one of the things you guys have taught me is just to be safe, doesn't hurt to kind of rotate it around and make sure that it's actually even.
Mm-hmm.
It can be a little bit uneven. So
Yep.
so far it looks like it's good all the way around.
Yep, and those calipers are great because they're going to give you a pretty good measurement, but the mill works a little more precise than your calipers do. And so there are ways that we'll talk about even further along the line about how we can get exact measurements and how we can kind of feed that back in and
Yep.
do that using the
Right.
precision of the mill. But this gives you a nice
That's-
little general sense, and you can buy some very basic digital calipers that'll get the job done. But if you're a little more serious about it and save yourself some headaches, you can get some that go a little further as far as how precise they measure. But with
Yeah, and
precision, there's more cost.
In case you haven't bought one of these before, I bought this one off of Amazon. It was the cheapest one, and it looks like it's exactly the same as the one Pete has. So it seems like it's kind of the workhorse, or is it? Do you have a nicer one?
Mine's considerably nicer.
Sorry.
I'm not going to talk too much about brands, but one of the things you want to look for is how far it measures, and how far you can get down to that. So,
I mean, that's
Right.
kind of,
how many places beyond the decimal that you can measure? Mine's going 4 deep. The mill, for the most part, we're working 3 deep past the decimal. So
Which is important because, like, a lot of you focus on creating projects that really show off the range and the capabilities of the machine. So a lot of times you're doing stuff that is extraordinarily precise.
Mm-hmm.
You were actually just showing us a little project before we started recording that I think illustrated that nicely. But if you go to anybody tuning in, go to the Bantam Tools Instagram and you'll be blown away by the stuff Pete and Amanda have been putting out.
Mm-hmm. Great. So we've got our stock measured. We had that was a little side tangent we were talking about considering stock size when we do our thing. Tony, you've already extruded out and created the ring. So we've got that shape there ready to go. And we've done a very, very basic design with CAD. So we've got that. And so I think, the other thing, this is worth mentioning before we move out of the design workspace, you can, if you wanted to, also just work with shapes and use other tools in here to actually sculpt and like bring it down and cut stuff down. So what you were starting to do is like, I could create a cylinder, or I was going to create a box or something like that. You can do that, and then you can start to remove things with sketches and extruding, or by combining different things together. You can do that. So there's a couple different ways you can go about doing design. This is a good starting point, and when you're just starting out, is to go this way. But I encourage you as you go along to explore some of the other options. You can build things in CAD. Lots of very cool things can be done here.
I'm glad you pointed that out though, Pete, because it's very true. Like I watched we did a live stream with Autodesk a few months back now, gosh, time has really flown. And I remember the gentleman's name is Graham. He actually started with the cylinder and worked his way down.
Mm-hmm.
And so it's just interesting to watch, like, people's, like, different people have different approaches, but also depending on the part that you're making, that can also be a determinant on, like, which your style of design choice, basically.
Mm-hmm.
And I'm just going to say again, it's so helpful to be able to step through this very slowly, because it's very easy when kind of faced with this interface to feel a little bit overwhelmed. And I think that our projects do a really great job of stepping you through every little bit of it. But if you accidentally kind of diverge from the plan, it's very easy to get kind of spooked by all the different pieces. So being able to walk through this really slow and deliberate makes somebody like me feel a lot more comfortable. And I can't wait, after I've gotten through this, to just start ripping through projects by, putting them into the software and milling them out. So thanks to you guys for that. So where do we go from here? What do I do next?
You got to go over to the manufacturing workspace.
Ooh. All right, let's do it.
Actually, before we hop right into manufacturing, I think what we should do is just talk briefly about the post processor that we're going to need for G-code files, and also the tool library. I don't know if that's getting too far ahead of ourselves, or we want to wait and program our tool paths and then talk about that. But we're going to need to go to the manufacturing tab regardless.
Yep. So let's head on over to manufacturing. And so if you recall, that was the little drop down. Now we have the manufacturer tab. Great. And when that loads up, you're going to see everything change across the top, like Tony mentioned earlier. So now we have a different set of tools here while we're in the manufacturer workspace. And so I guess, Tony, one of the things that we need to consider when we're doing this, and what we just kind of want to wrap our head around, I think you've explained this eloquently before in the past, which is ultimately what we're doing. Since we're working with the desktop, Bantam Desktop CNC Milling Machine, it is a 3-axis mill, which means that we're going to be moving apart. And we're going to be moving apart and back and forth, and we're also going to be moving a cutting tool back and forth, up and down, and we're going to be coming at it from one specific direction, from above. And so with this design, that's perfect, because we don't need to do anything terribly complex as far as how we program things. We're just going to be coming down with the cutting tool from above. We're going to cut out of that metal that he measured, and we're going to cut down the circle in the middle, and then we're going to cut a circle around the outside, and we're going to liberate that ring. And that ring, just because you're wondering, well, what happens when you cut all the way through, don't worry, we'll talk more about it a little bit later, but we're going to ultimately fix it down to the bed of this PCB mill with some high strength double-sided tape, which will hold it right in place. And so what you do is you get rid of all the metal, and it'll be left with just the ring and the tape that it's sitting on. So
and the nice thing is, once we load this into the Bantam tool software, you'll be able to really visualize what that will actually look like with the material and the space that's going to be cleared by the tool around it. So you can really double check yourself. Sometimes I've loaded a design into it and realized that it wasn't going to cut the thing out in the right way that I kind of wanted to. So I needed to kind of adjust my settings and make sure that the plan was going to work the way I intended it to.
All right, so I guess tool library. Amanda, you've quite literally written the guide on this.
Yeah, so step one, Tony, I don't know if you've already downloaded the tool library from our support. You have, okay, you downloaded it. And so
we might want to step through it again just to double check.
Yeah, I would say let's step through it in real time. So Tony, if you can go, because you're sharing your screen still, if you can go to, in the toolbar, if you go to manage, and then the icon with the tools, literally like right all the way to your left, you can click there, tool library, or the icon right above it. So either way, it'll bring you to the tool library. And so this is kind of like one of the beautiful things about Fusion 360 is you have all these tools that you can save right into the software. And so you have like all these different tools to choose from, but the tools that Tony is scrolling through, they're not necessarily specific to the Bantam Tools Desktop CNC Milling Machine or the Bantam Tools Desktop PCB Milling Machine. And so we have, created a tool library of the tools that we carry in our store, tools that we use quite frequently, frankly, the ones that we've tested with the mills with our mills. And so right now, Tony already, if you can click over to, right, we're in it right now, right? Yeah.
Yeah.
I want to clarify real quick, when you say tools, what we're talking about, that's kind of a general term.
We should probably. So I'm sorry, end mills.
No, it's all right. Yeah. So end mills, no, it's a cutting tool, and it's in this case, it's an end mill.
Right.
And I've got a couple that I'm gonna be holding up here that I just had within arm's reach. But I'm not sure if you can kick me over so we can all see this, Tony. But I kind of wanted to show off some of these different end mills.
Oh yeah. Hang on, I'll kill my. Yeah, there you go.
Okay, great. So if you kick over to me here, what you're going to notice is we've got a couple different things here with the end mill. So what I'm going to try and get to you, if it'll focus here. Anyways, this is an example. This is the type of end mill. It's a cutting.
You're going to focus right about there, Pete, if that helps you out.
Yep, perfect. So as I balance sharp, pointy tools at arm's reach. But anyways, this is an example. This is a 1/4 inch end mill. So this is a little bit larger. And this thing is designed for engraving. And so it's got a fine point on top, and it allows you to etch in the middle. So this would be something like you've probably seen done before, like on gifts and things like that, where some sort of inscription, always and forever, yours truly, Pete, right? Something like that. I'm much more poetic, but not on the spot. So that's an example of an engraving bit. Then here is a flat end mill. That's the helical. This is the helical end mill. This one's a little different, but it's pretty similar to the one that ships with the CNC mill. Mm-hmm. As you can see here, it's actually got it's got a flat end. Okay, this is sharp. I've gotten my fingers pretty used to touching these things, but it's got so do as I say, not as I do. Anyways, it's got a flat end to it, right? So that's the flat end mill. Which means that and it's got these, and this one specifically has blades on the end that allow you to cut. So it'll rotate, and it will basically shave away bits of metal that is the shape of the mill. So it's a circular shape, shaving away bits of metal. And that's an end mill there.
I mean, to give people a better idea, not to cut you off though, Pete. So like for the flat end mills, we especially for our machines, we typically like to use the flat end mills for adaptive clearings, contours, that type of stuff. Just because like you were given an example of like when we use engraving tools and that type of stuff. But let's see the Datron 12 millimeters.
So this is a different type of flat end mill. This one's stepped. So it sticks out further than the actual shank of the mill, which is important. This is the shape of the mill. It's the shank. And then the actual cutting head is here. And this one is technically 2 flutes, meaning it has 2 different ways that it can expel the chips out from it. Because as you cut, it creates debris, and you want to get that out of the way. Think about when you cut with a saw. All right, you've probably used a handsaw and you've made a birdhouse at some point in your life, or at least others do it, right? It's the basic shop project, right? And so when you cut with a saw, a handsaw creates dust. Those are small little bits that are left behind that were pulled out by the teeth of the saw. Same sort of thing. We're cutting with these end mills, and they will create small metal chips. We just need to get them out of the way so we can continue to cut. We don't want to get them. They just want them out of the way. We don't want them there anymore for a lot of reasons I'm not going to get into right now. So there's that. And then there's also, I don't have handy, but there's also then other types of shaped end mills that are like a ball end mill. So it's rounded, so it's not flat. And then you would use those for like rounded surfaces for finishing techniques. But for our purposes today, flat end mill is going to work. We're going to design around that idea that we've got a flat end mill. Probably a 1/8. We'll take some measurements. We'll find out. But we're probably going to design around a flat end mill that can then come down, cut inside the circle, cut around the outside of the circle, and we're done.
Yep.
And we're just gonna try and keep it super basic on that. So thank you for allowing me my tangent.
No. Well, I mean, to bring this back to the reason why we got into this in the first place, like, and because Tony kind of mentions jargon, a lot of that type of stuff, like. In our community, like I call end mills tooling. Like that's kind of like my go-to. That's how I often refer to it. But tooling, end mills is usually interchangeable a lot of the time. So, going back to that, like if you're totally new to this space and somebody, says, oh yeah, like I'm using 1/4 inch tooling, that's synonymous with I'm using a 1/4 inch end mill more often than not.
And usually they mean the shank, the wider part of
Correct.
because it's a 1/4 inch thing. The
Correct.
PCB mill is designed around, that Tony's using is designed around 1/8 tooling. It can go up to a 1/4, but it's primarily designed for 1/8 tooling, and I encourage you to stick within that for best results. And then the CNC mill is built around 1/4 inch tooling, but it can also do other sizes in between. So it can do 1/8 inch. We can also do 6 millimeter,
Right.
which is pretty close to a 1/4 inch as far as size goes. But that also allows you to use different tools from various manufacturers, because some manufacturers work in metric and some work in
Right. Exactly.
standard.
Sorry, Pete, I think I might be getting confused. You mean the 1/4 inches? There is the shank diameter, but there's also the cutting diameter. Usually when we're talking like 1/4 inch tool, like that's like the cutting diameter. That's like the actual tool that's using to cut the material away, right?
Well, yeah, the shank itself, and then yes, or depends. It depends where you're going, because they might go further, be like, well, I used a 1/16 inch, flat end mill with a 1/4 inch shank, or I use a 1/8.
Right. Yeah. No, we're on the same page. Yeah. I just want to clarify those things, because these are the numbers that I feel Tony's eyes are glazing over at this this very interesting
I'm sorry, Tony. I'm sorry.
But this is the thing. Like on I just had this conversation the other day with someone who reached out, and they were looking for tooling for the PCB mill, and they were just like, I'm looking to cut more plastics. Do you have any recommendations? And I was like, yeah, you want to look for like, I gave him a couple of Harvey tool recommendations, but I was like, you want to make sure that you have an 1/8 inch shank diameter. And we had this whole conversation, and I realized, I was like, it's an 1/8 inch shank, like meaning what goes into the collet, but then like the cutter can be different sizes. Like you're going to see like a bunch of different numbers, because it was like one of the first times he had done a tool haul. And so, yeah, like it's all these numbers come up, like it's completely like we get into the weeds on this stuff, but these are the types of questions when you're looking for specific tools for specific materials or specific jobs. Like you want to know that these things exist.
Mm-hmm. And so
we've completely gotten off into the weeds.
It's important, because as somebody who's new to this, I have a little bit of trepidation around, well, how do I use these different combinations of tools and materials and the different ways of traversing them. And right now, I'm wholly dependent on the Getting Started project guides to say, well, if I want to mill an aluminum ring, the guide tells me to use a 1/8 inch flat end mill, and I've got one that has that label on it. But I don't really know why I'm using this one as opposed to any of the other ones in my box. And the moment that I strike out to start working on one of my own projects, it becomes much trickier for me to feel comfortable working with these different tools. So it does merit a good amount of thinking and conversation to get comfortable. Although I do think that, like many other things in life, just by stepping through a Getting Started project, I start to get comfortable with, well, I just did a project with a 1/8 inch flat end mill, and I used it in aluminum. So if I want to do another aluminum project, I know at the very least I could use this one. Exactly. And then I could kind of expand out. Well, if it's an 1/8 inch, I could probably use a flat end mill of a different size, and it probably will still work, and go from there.
So we're loading a tool library which has this stuff pre-programmed in there, the shape of the tool, the shaft, the length, all of it, how much it can cut, the how small the tip is, that's doing the cutting, the shape of the tip, flat, round, pointed, all those things. So that's what Amanda's walking us through here, which is how do we get that information into Fusion, so that way when we start to talk about pulling a tool through metal to cut, that we know that it's going to do the right thing, because Fusion is going to basically help us, and we're going to help it. We're going to work together with Fusion, and we're going to create paths that account for the tool geometry, is the term you'll hear used, which is basically the shape of the tool.
Ultimately, what we're doing is, like, we're going to use the tool to cut through a material, and this thing's going to spin around and it's going to move through, and we're going to have metal on metal. I mean, this thing's going to be pulling shards of metal off of this thing, right, and cutting it out, chips of metal, as it were. And the physics of that have to potentially be a little bit precise, in the sense that I don't want to break this thing. I don't want to fling this thing or warp it or mess up this material in some way. And the size of this is going to affect the size that I cut into this thing. And so depending on what I'm going to create, this size is either going to be important because I want to be able to take out a lot of material quickly, so I want a big one, or I need this to be pretty small and precise so I can make very precise kind of etchings or measurement or cuts into the material, right? So the software needs to know, what is this thing? How big is it? All the things you just mentioned. So we need that library to be loaded into the software so that the software knows what we're working with. Right. And we've got the default set, Bantam tool cells and mills that we've used and tested with the machine. So there's accessories that make this easier. And of course, if you buy your own tooling, you can try to look it up in the software or actually load it in manually and create that and adjust some of those settings. Yep. So should we jump back into the software and kind of keep going from there?
Yeah, totally. I mean, really, I think like we've kind of covered a lot of like the important things with the tool library, Tony, and also like jumping off of what you said, if you do want to, if you get a tool that's not in our tool library, you can totally enter it. You can create your own individual tool library. I see you've already got Tony's tool library in there. I know I have Amanda's tool library in there of tools that I just use regularly. Like that's kind of how I use my library, and that's how I organize it. Everyone has their own style for that. And I guess the one additional thing that I will add, and this is something that I think will segue nicely into kind of our conversation about tool paths and programming them. Each of these tools that are in this tool library, they come with, we've kind of preset speeds and feeds parameters. So in terms of spindle speed, feed rate, that sort of thing. And so, you know, you have a jumping off point, whether you're working with the desktop PCB milling machine or the desktop CNC milling machine, as you start to begin to program your tool paths. And again, we've done a lot of in-house testing and running. And as you guys have probably seen, if you follow us on social, there was like a period where I think like every other day we're like, new recipe. Because we were just like, we were having a lot of fun with it, but it's really like to dial in those speeds and feeds. Like we were hammering it like constantly.
So I'm just looking at this. I just clicked one of these tools, which I believe is the one I have, the 1/8" flat end mill. Yep. And I'm scrolling through the info here where it tells me the physics of the actual tool, the diameter, the shaft, the length, all those things. But then if I scroll down, I can see the cutting feed rate, the feed per tooth, lead in. And I have kind of a vibe for what each of these is. And I don't need to have intimate knowledge of it, but I get the point. How much it's going to move across the material and how fast it's going to spin. And so this is ultimately something that the team has put together through trial and error and through some math, so that you have the best chance of this tool performing as well as it can. And even a product link, which is great. So if I see one that I don't have that I might want to grab, I can go right to it, which is awesome.
And I do want to stress a little bit as I'm looking at this, and this is a whole nother conversation, a whole nother thing that we're going to be doing here in the coming month or so when we start talking more about feeds and speeds. It's a whole ball of wax that we will. I don't want to get too into right now, but I just want to point out, just as I'm looking at these, Tony, that the default feeds and speeds that we have here are actually pretty conservative for aluminum, and so we'll be modifying those when we start creating our tool paths.
Even for the PCB mill, these are pretty conservative, I think.
Yes, they are. Even for the PCB mill, they're pretty conservative.
So for our CNC machine, we're going like at 50% right now. That's what the defaults are at, I think.
And the other things that we'll eventually talk about, and I don't want to touch on yet today, and I'm going to let you get back to Amanda about how we get this information into Fusion. But the other thing to consider is what we're cutting out of, because obviously we can cut quicker through things like plastic than we can aluminum, because plastic is softer. We can cut quicker through wax than we can plastic, because wax is pretty much non-existent. It's pretty much air. So, right. So there's some things in that, but that's, we'll get into that. So how do we get this stuff that Tony's looking at? How do we get that stuff into Fusion? Because that's not in there by default.
No, it is not. And so I think the best way to do this would be, actually, Tony, if I could share my screen for like 1 second, I think that might be
go for it.
The best way to just show this really quickly.
Yeah.
So if you're looking to download the tool library, you will want to first go to our support page at Bantam Tools. And so you would go to operating the Desktop CNC Milling Machine. And then under workflows, we have quite a number of articles for you guys to kind of pick through. And so we're going to go to Fusion 360 Workflows Programming CAM. And so if you scroll down, you'll instantly see in the support guide, you'll learn how to import a custom tool library into Fusion 360. So we're going to hop all the way down into the first section. And so the first step that you'll want to do is you'll want to download, please. Thank you. Download this tool library. And then as you'll see in Fusion 360, you'd be in the manufacturing tab. If we went into the tool library where Tony just was, you will see, let me see, what this should be import, right?
And it's contextual. It depends on what you have highlighted.
Yep. Import. And so once you've downloaded the tool library from that our Programming CAM support guide, you can go into import tool libraries, and then you'll be able to click on that from your Finder, which we have here, and you'll be able to import that into the tool library in Fusion 360.
Great. So
I mean, I already have mine loaded up, so I don't want to like do double.
Yeah, no, exactly. You'll double it. So the short of it is we'll head to the Bantam Tools website and support section.
Exactly.
When you walk through the guide that talks about the stuff we're talking here, there's a direct link for it for that little file. And then using in the tool library window, like Amanda was showing, you're able to import that, and it's going to have all those things in there. Tony's already done it. Amanda's already done it. So we're ready to go. There's more details in that detail guide that Amanda put together.
Yep. It's actually just like once you like know where to go, it's a very like straightforward process. That's kind of half of to Tony's point, like Fusion is great. As soon as you learn like, oh, this is where I go for this thing. Awesome.
Great.
Exactly. And that's why we're here.
And why we are here. Let's program toolpaths.
Yeah, let's do it. All right. So I'm closing out the tool library. And now I'm back in here, and I'm seeing I could kind of like click on these surfaces, which is kind of fun. But let's get to the tool paths. Where do I go now? Now that we've got our tools ready to go.
All right. So we're actually, one of the first things we're going to want to do is we're going to want to create. So we've got the tool library done. We're actually going to want to create a setup. So we're done with the tool library, so we can close out of that.
Oh, I'm sorry. There we go.
And bear with me, I haven't been. I'm.
Okay. For some reason, it wasn't coming up, so I'm just gonna do it again. All right, we good?
Yes.
Okay.
All right. So what we're going to want to do here is we're going to go ahead and we're going to show Tony. I'm going to walk you through the best I can, describe it, and then if I have to, I'll take over and try it from my end. But I think we can do this as I walk you through it. So what we're going to want to do is we're going to want to tell Fusion basically how we're going to put the piece of whatever it is, aluminum in this case, how we're going to put it in the mill and what direction the end mill is going to be coming from, right? When we go from, when it starts to do the cutting. And so we got to tell it what's the top. We have to tell it this is the size of the stock. And so we're going to do those very basic things right now, and that's called a setup. And so the very first thing you'll want to do once you're going into your workflow, we've done our design, we've done the CAD, we've created it, we've now gone over to our manufacturer workspace. So under setup, you see that little drop down there, Tony? There's an option for new setup. Let's go ahead and do that. Now, cool. I'm going to talk a little bit to this before we start clicking on anything. So there's a lot that just kind of popped up here. And I know it's looking a little sci-fi like, and I'm going to try and demystify this the best I can. Okay. So what you're seeing here is we have a representation of the thing we made, the ring. That's the darker gray right now. And then we've also got this weird new thing that's popped up. Two important things. We have the outer box, which is that yellow. That is a representation of the stock or the piece of metal. I'm going to refer to it as stock, and that's kind of the common term going forward. That's the thing we're cutting out of. So we've got the stock. That is our stock box. And then we've got this other thing on there, Z, Y, and X. What that is, that's in reference to the mill itself. What that is, it's your work coordinate system, where Z is the up, in this case, for our purposes, Z is up and down, Y is forward and back, and X will be left to right. That coincides with parts on the mill that we're going to be moving. We can move the bed on the mill, which is what's going to move the stock forward and back inside the mill. That's on the Y plane. We can move the cutter, the spindle, left and right. That's the X plane. And then we can move that spindle up and down for depth. That's the three-dimensional side of 3D milling, is we can move it up and down while we're cutting. And that's the Z. And so what we want to do here is we're going to go and start at the top here over on the right-hand side, Tony. You've got your box, this little dialog box. It's got 3 tabs. We're in the first tab. And as you notice, as you start to hover over everything, it's actually going to give you some very helpful information. I'm not even sure what those were. I haven't seen those yet.
Yeah, I don't know what that was.
Okay. Well, anyways, we're not going to necessarily we don't need to do machine or anything like that. We can leave that alone. What we're interested in is the operation type that what we're going to be doing. By default, it's set up on milling, but go ahead and click on that real quick. So you've got some other options in here within Fusion. So if you're going to do a different type of thing, or a different type of, use Fusion for a different type of machine. In this case, but we're using our mill. So milling's where we want to be. That's where Fusion shines. So we're going to set up for that. And then that kind of gives you an idea of some of the different technologies that we were seeing that you can use for making things. But we like milling.
When in doubt, hover over the thing for a minute. It might just pull up a cool graphic.
And so we're going to go ahead and we're going to set our work coordinate system. And this is basically where they said we're putting a stake in the ground again. You know how we did it when we started designing? Now we're going to put a stake in the ground, and that's the stake that our software is going to use when it starts to read the code that we are generating here in Fusion 360. So in order to do that, we're going to need to figure out the orientation. By default, it looks like it's already done what we've done, but I want to go ahead. We're going to change the setting there. So you see it says orientation. Go ahead and click on that drop-down box. So we've got some options here, and what we want to do, and this is a good habit for you to get into, is we're going to select the Z-axis, and we're going to also select the X-axis. That's an option there. And then with each of these, the other ones, there's other ways you can do this, but ultimately it's going to figure out the third based on the other two, right? But for us, let's go ahead and select the Z, and we'll select the X. So in this case right now, you see how Z-axis, how it's highlighted blue where it says nothing? That means wherever you click next, it's going to basically set that. That's Fusion's way of saying when you click on some, this is what you're about to set. It's letting you know you're about to set where the Z-axis is. So in this case, let's just do this on the face of the ring. We're going to tell it like that's going to be the top. So if you actually click on the top of it, see how you start to highlight over? There we go, perfect. So let's go and click on that. So we're saying that orients it to the Z, and that's what we're going to want. And by default, since it's a ring, it doesn't really matter where the XY is. But if you wanted to, if you need to orient it some way, because let's say it's a piece that's really wide, but you start using the mill and you realize, hey, the mill's more deep than it is wide, I'm going to need to turn this thing. This is where you can start to do that. You can choose different sides of the model. Does that make sense, Tony?
Yeah, I'm kind of following. I think I'm not understanding yet why I have to tell it what these work coordinates are.
Mm-hmm.
I'm guessing that it's to try to kind of orient to what I intend, where I intend for the tool to kind of come from. Exactly. But I'm not sure why I'm picking those axes.
Great question, and great thing that I should clarify. Ultimately, what we're doing here is we're just saying which way's up. When we're choosing an axis, we're saying which way's up. We're saying which way is pointing towards the back of the mill, which way is pointing towards the front of the mill, which way is to the right, which way is to the left. And so that's what we're trying to do when we choose these axes.
And the other thing too, to your point, Tony, in terms of, it's like locating something within a certain space, right? And I think, again, like, as people, if you've done any, digging in the support guides, there's like this common graphic that we have of machine offsets, where it's like the front left corner is home base for the desktop PCB mill and the desktop CNC milling machine. And then from there, everything offsets from that point. So when you go to move, let's say, you run your material probing routine or you orientate your plan, everything is going to be based off of that corner. And so when you're in Fusion, you have to specify that corner. Like Pete said, you're putting a stake in the ground, so that way you can then basically, it's almost like back when we were doing the offset tool back in CAD, everything is going to be a chain from that one point that you choose.
Got it. So
that might be a little bit more general, but that's how I like to think of it, and helps me, like, it's basically placing it in space within, you're orientating your model within the stock, and then you're orientating the stock within the machine.
Can I say, would it make sense that, because Pete, when you mentioned in the beginning that I could draw it from any direction, because it won't matter, essentially it's because we're going to orient it later. And
exactly.
So, and for example, if I'm using a more complex project than basically a ring that's just a flat circle, it might not be immediately obvious when I'm doing the design how I'm going to want to orient the cutting of it, or it might change for various reasons. So it's basically, there's the drawing, and then now we're going to orient how we want the tool to orient itself around this, like how we're going to set this up. So yeah, I think I got you now.
Okay, great. So what we're going to do then is, the next thing we're going to do is that our software by default, like, I like it is like, this is home base. This is where everything's based on.
Right. Exactly. Like, I think that's like the best way to think about this is home base. Like, and you can, like, having that ability to just remember, like, this is where you're putting the stake in the ground. I think that's like the best analogy, Pete, to like just keep in mind when you're doing CAM, because it's just going to feed in through like the rest of your process until you get to machining.
Exactly. And so one of the things that we're going to need to do here now, the next part, is we're going to tell it where that stake is, right? So by default, it's putting that stake smack dab in the middle of the stock. In this case, so it's right smack dab in the middle, and it's going to say, oh, it's going from there. It's going from the center. Well, the thing is with the Bantam Tools Desktop CNC Milling Machine, the Bantam Tools Desktop PCB Milling Machine, for various reasons that we're going to learn more about later, we orient things off the front left corner of the stock. And so we want our code to be referenced to the front left corner, and we want our stake in Fusion to be on the front left corner, or the top left corner, front left top. There we go. Three directions. I knew there was another one in there that was important.
It's three descriptors.
Three-dimensional space. I knew I was forgetting one.
Before we get into that, do I have to click something for the x-axis? Right now it's still on nothing.
Nope, okay, we don't need to do that now. It's a ring.
Can I, so does that mean I pull this guy over?
Not exactly. I'm going to show you how you do it. You got the right idea, but if you click on box point on the right, stock point, great.
Okay, box point.
There we go. It's ready to go. It's highlighted blue. It's expecting you to do something. Let's go ahead and click on that little dot on the top left of the stock box. You see it over there to your left? Move over to your left on your mouse.
Oh, over here.
Yep. Mm-hmm. So all those little dots are places where you can start to align things. And so if you click on that, hopefully, boom,
snap.
There you go. So now we're aligning, all the code that we're going to do is going to be referenced to that point. Later in our software, we're going to set everything up to go off of that same point. We're going to measure where that is in physical space, because that's going to,
this is the top of the material, on the front of the material, on the left side of the material, and it's going to correspond to the bed that the material is going to be placed on in the machine as well.
Right. So that corner that you just picked, that's going to be corresponding to the front left corner of the mill. So it's like point.
Yeah.
Yep.
With the PCB mill. Yeah, exactly. And then we're going to realize how powerful that is. Like, I cannot stress enough how important it is that you get this part right and that this is set up, because when you eventually load into our software, everything will just click into place. Yep. And so this is where you're making the connection between digital and physical. It's all based off the WCS, the work coordinate system, where you are putting the stake in the ground, because we will calibrate. We've calibrated digitally now where the stake is, and eventually we're going to calibrate physically where that stake is. And as long as those are lined up and perfect, everything will turn out exactly as you program it, and it will do exactly what you want. So it's super important. So we've gone into our manufacturer workspace. We created a new setup. We've defined where the top of it is, the Z-axis, and the XY is defined for us, and then we've also now set where the corner of the stock is going to be, or where the measurements are going to be measured from, which is in this case the corner. So that's it for this tab, but stay in this dialog box. So across the top there in Fusion, you've got options, and we're going to go over to the next one, which is stock. Okay. So we've got some couple things here, and let's go ahead and take a look under mode. We'll just start from the top and work our way down. This is going to be a common Fusion thing as we go through in the cam side. And so we're going to work with a fixed size box, because we know exactly how big that piece of aluminum is, because you've got those digital calipers. So let's go ahead and click on fixed size box from our drop down. And now it's going to give us some options here. So what it's asking now is what your width is, what your depth is, and what your height is. Those are the three things we're going to be really focused on. Are you with me so far? I want to check in.
Yeah, I got you. I just wanted to make sure I had the measurements handy of my actual stock.
It's roughly 4.01 inches by 4.01 inches by 0.6. I've done this a few times.
We know it's 0 point. It's 0.06.
It's the one from our store, so it's slightly larger than 4 inches by 4 inches, and for our purposes, that'll be good enough for what we're doing today. We don't have to be as precise since we're doing one piece. And then, all right. So now let's go ahead and if you use your mouse wheel, you can zoom out a little bit in Fusion. Or whatever I'm not sure what you're using, trackpad, whatever. So here it is, and now we've got this ring. And it's like, okay, we're going to cut it right out of the mill. You know what? I think that's a very inefficient use of the metal. What do you think?
I agree.
Okay, so here's where we can start positioning it. So you notice that under each of those things you just set, X, Y, and Z, there's now a model position. And currently it's all set to center. Okay.
I wonder what would happen.
There you go. You've got it. So we're going to do offset from the left, and we're going to do it maybe 10 millimeters. It should be enough. And then do the same thing for the model position. We're going to offset it from the front. And we can do that about 10 millimeters. And then now, this is where it gets interesting. In this case, we made our model exactly the same size as the stock, didn't we? 0.6?
Yes.
Okay.
Roughly, yeah.
So there's really no room. For giggles, this isn't going to be the case. Can I actually have you change what the height of the stock is just for demonstration purposes? Let's just say it's 1 inch.
Sure.
Thick. So a full
1
1
inch?
Yeah, let's say 1 inch. Great. And now,
Hang on.
no, we don't.
I might have.
You got
I
it. You
didn't
have to
probably
click.
expect
You have to click
millimeters.
inches.
Yeah, which is something you can set up in your Fusion settings later. Okay, so now if you were to use your little navigation cube in the top right, go ahead and click on. See where that at the top right? Go ahead and click on where it says front.
Yeah.
Or just move it.
I can see what you're talking about. Right now, the same way that we're orienting the project to the stock along the other axes, if the material's really thick, we're telling it to carve inside the middle of the stock, which is never going to work. So we need to be able to.
Well, it will, but it's kind of like it's not ideal. It's inefficient, and and we need to get the stuff off the bottom. So basically, what we do is we want to pin the ring up against just one side of the stock. And I think your instinct here was to move it up, right? I want you to think differently, because you're going to be carving from the top, and ultimately, you want that piece to be free. Because if you
want it to go all the way through to the bottom,
you want it to go all the way to the bottom, right? Otherwise, you're going to have this beautiful ring on top of, in this scenario, nearly a full inch of extra metal. You're not going to be able to wear that thing around. So pretending that our stock is this thick for now, let's go ahead and we're going to do an offset from the bottom. And then we're going to change that to 0. Oh, that's also good. You actually got ahead of me there. Hey, no problems. If we hit enter and we closed out, that's okay.
What?
So we accidentally closed out the setup, and that's okay. We're going to get back into it. So on the left hand side, do you see where it says setup number 1? That's the setup we
I
made.
do.
If you were to double click or right click on it, we'll have an option for edit.
Ah,
There we go.
but ding, back
And
where I
now
started.
we're back, and we are. So we were trying. We were gonna. Oh, we're also on the second tab. So we'll head back over because we've done everything on this first tab, and so we're gonna go to the second tab, the stock. Remember that
Yes.
term we
And
talked
we were
about?
gonna offset
Stock.
from bottom.
Yep.
Yes.
And we're going to offset from the bottom. And then we're also, in this case, let's go completely to the bottom because we're going to want touching the tape. Great. And then I do want to go back, and you're going to get really good at going back into this because I want to point out one more thing, which is round up to the nearest. When you were going through, you remove that, which is the right instinct, because we don't want to round at all. We're measuring things. So what's the point in rounding? So let's, you can just set round up to the nearest at 0. This is good for our workflow. In some workflows, you might just be creating general code, throwing it in. You've got the slop, you're moving quick, you're doing a lot of things. Maybe you want a generic thing in there just so you can go. And so there is purpose to have it round to a certain shape because you don't mind if you go over, but we're trying to be efficient with our design and the amount of time that we're going to spend cutting. So we're going to round up to the nearest 0. So we're going to flatten that out. And then that's all we actually need to do here. I do want to point out, just for handy reference, if you were to scroll down on this window, you see where it says dimensions on the bottom? X, Y, and Z. Those are the numbers that we put in when we were doing this. It's just a recap of what's above, but it's a great little place just to keep you focused. It calls them out because you're going to use those numbers. We're going to enter those into the Bantam Tools software later because we're going to say it's this, and here's the stake. And so that we put in the ground. So those numbers, just for future reference, just remember they're there because you're going to come back to them later. Okay. Jot them down, whatever you got to do. But we can pick those up again later. So let's go ahead and we can close out of there.
Do we want to set our thickness?
We do, but since we're here, yeah, let's go ahead and set our thickness back to what it was, which is 0.6. So we were just trying to illustrate what it would look like. Point zero, was it 0.6?
Yeah, 0.06.
60 thou, or is it 0.6?
No, 0.06.
Oh, that is a small ring.
Yeah, it's super thin ring.
That is a thin ring.
Right? We're talking about material that's
okay.
Well, listen, it's okay. This is take 1. We can make chubbier rings later down the road, guys.
Okay. So we've got that. So we've done today. So we've done a lot so far, and I want to kind of we're going to bring this to a close with just one more thing, just to kind of preview what we're going to get into later. But I think we're just going to, there's a lot to it, so I don't want to dive too far into it. But just recap, we've gone through, we started with the sketch, we extruded this ring out, we made a ring using dynamic measurements. So if you change one, the other one would adjust to it. So we've created this ring, we've gone into our manufacturer workspace, we've imported our tools, and we've got the tooling geometry ready to go. And we've now set up our stock. Representation of the piece of metal that you've measured and that you had in your hands, and we have now situated the thing we're going to cut out of that piece of metal inside that stock in the digital space here in Fusion 360. So let's cut the thing out.
Now we're going to make some tool pads.
Let's make some tool pads.
This is the thing that everyone always sees on YouTube.
Yes, and this is the sort of thing we show, and this is where it's at. So just a general overview of tool paths. Just kind of where they are, and we're just going to put one in by default, and then we'll come back to it. But under toolpaths up top, you've got a couple options. We've got 2D toolpaths and 3D toolpaths. Just for today's purposes, I'm going to have you choose a 3D toolpath. So if you click on the drop down where it says 3D up in the middle on the ribbon,
okay,
you've got some options. The workhorse for just roughing things out is adaptive clearing. That is Fusion taking basically, go ahead and just scroll your mouse over these real quick. I just want you to show these real quick as you roll over. It's going to give you those little previews. You were showing some of this earlier, but each one of these things that we're doing, as you go down, you're going to see that there's different types of strategies, ways in which you can go about cutting the metal, cutting the thing, cutting the stock. And so what adaptive does, and this is unique to Fusion, the adaptive part, what that does is that's going to take all these different tool paths, and it's going to basically take what it thinks is best, and it's going to kind of mix them all together. And so it's going to try and it's usually pretty good, is efficient enough for our needs today. So we're going to do adaptive clearing. So let's just go ahead and choose that. And now we've got all these things that popped up, and there's 5 tabs. I'm not going to go terribly deep into these tabs quite yet. That is for next time. But just so we can have a line and we can feel like we've got somewhere on this, I'm going to have you actually select that tool that Amanda walked you through earlier, and do that. So on the first thing, select on the top. Great. Here's our tool library. You mentioned you found it in the list there. There's a couple things. 1/8 inch, great. Flat end mill, great.
We'll press OK.
Perfect.
Great.
There's things that we can change with spindle speed. We can tell it.
The shadow of the tool is now hovering over the surface.
This is the part I want us to get to. I just want us to see this and just get a glimpse.
Yep. This is where it gets like, again, like I know we can get way off into the weeds, and we're going to go deeper into this next time. But like, one of the cool things about Fusion, and this is a great tool for anybody starting out, even like if you're even people who like machine on a regular basis use this. Like Fusion has like a very powerful simulation tool that allows you to like, you can like divvy out like different, parts of your stock and all this type of stuff. It's like, it's a whole world. I love it. I use it all the time.
Nice.
But yeah, that's it. You get to see the shadow of the tool, and it will change
depending on the tool you chose.
Yeah, exactly. It'll show you the tool geometry, which is really going back to what we mentioned earlier. Like this is super helpful to start to begin to visualize how these tools will cut the material, cut the model that you've designed.
Because there's certain considerations about it. We'll talk about that when we simulate tool paths.
I'm gonna pause on that.
I just real quick, just want to click through those tabs real quick, just so we can get a quick glance at them, and then I think we'll probably riff. So geometry, there's some things we can change here. Great, more fun things. Heights is an interesting one. This is saying where the bottom of the tool is, where the bottom of the stock is, how far it should move up when it retracts the tool, and then we've got passes. This is another important one where we can start talking about how much of the tool is going to engage, like how wide is the cut going to be, because you're not going to use the full tool for reasons that there's a myriad, but you're usually not going to use the full tool.
For example, Pete, in a project I was working on last week, I noticed that the tool seemed to be going over the same spot over and over and over again without really clearing much material. And it seemed like it was just erring too much on the side of
being
caution.
too cautious.
It was being too tenuous. This is where I might be able to kind of mess with that setting. Is that true?
Exactly. So that would be step over, which is another term, but basically how much of the width of the tool is engaging. So, 100% of the tool, part of the tool. In this case, we're actually going to talk in actual measurements or our goal for it, because adaptive, but that's a little different.
Right,
but those are the things we can do here.
Probably in our next conversation, we'll probably mess with these things more and dive
exactly.
deeper. Yeah.
We'll talk about how wide we cut, how deep we cut. Whereas the first thing we're looking at was how fast it spins, how quickly it cuts, left to right, forward and back, whatever. So those are all things there. And then linking has some more advanced stuff in there as well. And so in each of these tool paths, you're going to have these different things. Now these will change a little bit based on the tool paths you choose, but we're just going to leave it at default now. We chose a tool just so it has something to work with. I just want you to hit OK, so we can have the satisfaction of seeing a blue line. And there's satisfaction in this when you start to see something coming out of it.
Right now, it's.
This is.
There we go. There we go.
This is a wildly inefficient tool path we've created.
This is inefficient, but it's worth to see it. I won't lie.
So can I explain what I think I'm seeing?
Yeah,
go for it. Yeah.
We told it, hey, you've got a rectangle of aluminum, and what we want is just this little piece. And so the program said, okay, if you want just the ring, then I will use the tool to eradicate the entirety of the rest of the block.
Right.
So that only the ring remains.
Yeah. That's pretty much it.
Sorry, Pete, go ahead. I was just going to point out, like, there's a couple things here, like, immediately, like, that I'm gonna just point out, like, if you're more intermediate or advanced machinist, will see this immediately. But for somebody who's completely new, this is something that I did not recognize immediately when I first started. So right now we actually still have like a layer of stock even on this adaptive clearing pass, which means we're gonna have to like adjust our heights in that height tab that Pete was just mentioning. But that's, again, like, that's a whole other thing. Yeah. And then the reason, again, like Pete jokingly said, this is inefficient, is because you're cutting out the whole stock.
Yeah.
And next week we're going to get into more like how you, like Tony was saying, like, we want to cut this one little piece. That's what we're going to focus on to show you guys more about like creating that efficiency, thinking more about like, how do I save my stock? How do I optimize my mill time? That kind of stuff, which you can really get down into. And this is where Fusion, you know, everyone says like Fusion's such a powerful tool. This is kind of like the power of like a CAM software. Like, it tells the machine exactly how you want it cut.
Yep.
And so, all right. So if we just want to power through fixing this, tell me exactly what to do.
Tony, that is 20 minutes minimum.
Yeah, that's it.
I guarantee you. There's a lot. I know you're excited.
We gotta really pull back.
You can poke around in there, but ultimately you're gonna be playing with stuff in those first couple tabs where you're gonna restrict it to a certain area. You're gonna say, I only want to cut so far out. And then you got to also worry about the life of your tool. So you're going to want to worry about like, hey, I don't want to be that aggressive while the mill is powerful. It might not be that powerful. The CNC mill would have no trouble doing this cut. But the PCB mill would probably have a little trouble. It's a little it's not optimized for removing that much aluminum that quickly.
Yeah.
So we'll say this. For part one, we have gotten to the point where, technically speaking, we could export this plan, import it into our software, and mill it, and it can technically work. Now, the next part of our conversation is going to be, how do we make plans not suck? And how do we make them as efficient and kind of effective as possible? So tune in next time for that. Does that sound right?
That sounds beautiful.
That's actually, that's spot on. That's basically what everyone wants to aim for. You can see it on the title card.
Well, and I will say, this is an insane analogy, but when I learned like ballroom dance, there was kind of like, the first thing is learn the steps. So I know like what are the steps of this dance look like? And then once I learn that, then I can learn, how do I not look like a dummy when I'm doing this dance? So like technically I can do the dance. Now let me learn how to actually look good doing the dance and do it well and do it in a way that is sustainable and workable. So that sounds like where we're going to pick up for
practice. I still feel like I've done this. Like, I can make I made an adaptive clearing pass now, like at least like hundreds of times at this point, just like through practice. And there's still moments where I'm like, wait, what? No, I had to click that box. We've done this before. Why did not we do this time? It's totally like, it's one of those things where you get into the rhythm of it, but at the same time, there's still going to be moments where you feel like an awkward giraffe. But it's
fair enough.
Probably not the best. Like, a newborn giraffe is probably the better awkward giraffe. Anyway.
So, okay, great. So I think we're at a good break point here. I'm excited for kind of where we ended up. I've learned a lot, and I'm a lot less afraid of Fusion 360 now. And I feel like in our next conversation, we're going to be able to dig into this in more detail, mill the project, and then we'll feel really empowered to kind of work on a bunch of projects from here.
Yeah, it depends on how into the weeds you want to get. Well, yeah, we can do all sorts of stuff. It's awesome, Tony. Seeing you kind of go through this and kind of in as we push.
Learning real time is like literally learning real time.
And again, I made this analogy weeks ago, I think now, where I mentioned it's like learning to cook, right? You're not going to walk out of there and do a full Thanksgiving meal first time out. You're just not going to do it. You're probably having to do a full meal, but you learn to boil water, right? You learn to measure a cup of water. You learn all those things. You learn what the tools do. So we're getting there. And we're building on it. We're moving forward. So I'm very excited. And I enjoy walking through this because there's
already like so much more comfort. Like, I don't know if you feel more comfortable, but I feel like you're more comfortable navigating the interface like way
So
more.
much more.
Yeah,
Oh, yeah.
exactly. Like I can definitely see like if there's like, oh yeah, like I know exactly where I want to go for this one. I at least know where to like poke around. That's like half of the battle. I feel like
Yeah, that's a
because there's
start.
so much at your disposal, and you're like, where do I even start?
I got a toe hold, and that's a really good starting point.
Mm-hmm.
Well, thanks, guys. And let's pick it up for next time. And I hope to everybody tuning in that this has been really useful to you. I know, as you can see, we are a team of people who are just really, really passionate about this. We are excited learners, and we're learning right alongside you. And we're learning how to communicate these things as well as best as we can. So if you already have one of our machines, we're here to support you in making this process as easy as possible. And if you don't, check out what we've got, bantamtools.com, and Bantam Tools on all the socials. And I personally highly recommend checking out Instagram, where these two are just posting some really, really awesome projects so you can see just what these machines are capable of doing. And until next time, thanks everybody for tuning in.